We are going to be using the term predictive model and the term model quite a bit in this course. It might be a good idea for you to really understand what we mean by those two terms before we start actually working with models and so on. What I've noticed is quite a bit of things about any new learning is about terminology. Once you understand the terms very well, everything else becomes actually quite easy. And if you don't understand the terminology well, then everything looks magical and complicated. Okay, so that's what I'm trying to do here, to really clarify in simple terms the meaning of two important words that we'll be using: predictive model and also the word model itself. Okay, so what is a predictive model? Okay, so let's take a very simple example. Okay, so here I've got a data set in which the first column is quantity. The first attribute, if you like, is quantity expressed in kilograms, and the second attribute is total cost, presumably expressed in dollars. Okay, this is all we have. And let's say, take a close look at the data and see if you can notice any pattern. Okay, so take a minute, take a very close look at the data itself and see if you're able to spot any pattern. I'm sure you will. Okay, so you can stop the video, take your time, and once you're ready, you can continue the video. Okay, so of course, what you notice here is that clearly the price, the cost is always double the quantity, right? So if the quantity is 1.2, the cost is 2.4. If the quantity is 0.3, the cost is 0.6. The quantity is 3.8, the cost is 7.6. So it looks like the cost is always 2 times the quantity, or in other words, it's the price of whatever it is that is being represented here is, let's say, $2 a kilogram. Okay, so this is what you got by simply looking at the data. Okay, so of course this is historical data. You're given this. Now based on this, suppose I ask you, tell me what is going to be the price for these 4 things, for 3.2, 0.7, 1.4, 1.3. Well, you may say, well, the cost is always twice the quantity. So obviously the cost for this is going to be 3.2 times 2, which is 6.4. The cost for this is going to be 0.7 times 2, which is 1.4, etc., etc. Okay, so therefore you might make these predictions, right? You'll be able to fill these in based on the pattern that you observed by looking at this. Okay, so effectively, if you looked at this, congratulations, you just built your first model, right? So you inferred that the total cost is 2 times the quantity, double the quantity, and therefore you built your first model. You built your first predictive model, right? So what effectively happened was, I showed you this data. Based on this data, you learned the underlying pattern, and then you were able to apply that pattern or model to future cases, right? All these are future cases that were not shown to you before, but they were shown to you later, and you were able to determine a value for those based on what? Based on the model that you built, the inference that you performed, which is your model, based on the data. That's it. This is really all that is, that is involved in understanding the term model and understanding the term predictive model. Okay, so it's as simple as that. So all you're doing is looking at some historical data, identifying an underlying pattern, and applying that pattern to future cases. So in a business context, you're doing the same thing. You've got historical information. You look at that historical information, understand some underlying patterns, and then you say, okay, that's the basic pattern. In future, something comes along, you can make predictions for that based on the pattern. Okay, so basically what you did was you learned the underlying pattern by examining the data. You looked at the data and figured out that this is the pattern, that the cost is always 2 times the price, 2 times the quantity. Okay, so that's all really happened. Of course, this is clearly a trivial example. Real life is not going to be as simple as this, and so on, but this is what is generally going on. Okay, so in predictive analytics, you have historical data, right? So you use the historical data to build a model, In this case, your process of building the model was simply you looking at the data and understanding a pattern. That's all it was. Okay, so you use the historical data to build a model. So in our example, what is the model? The model is that the cost is 2 times the quantity. That's your model. That's it. So you can use that model to make predictions for the future, right? So here come 4 cases for which you don't know the value. You can now apply the model and arrive at your predictions. Okay, so these are predictions from the model for the new data. So predictive modeling, at the core of it, is nothing but finding underlying patterns. That's it. Let's understand a little more about what we mean by these terms. Okay, so same data once again. We're looking at the same data. But suppose somebody comes along and says, my model is total cost is 3 times the quantity, or total cost is just 100 fixed. Okay. Now you may say, well, why would you say that? Why can't you look at the data and see that the total cost is 2 times the quantity? Why would you come and say something else? 3 times the quantity or 100 doesn't really make sense. No, the point is, in modeling, can you say that this is wrong? 3 times the quantity is wrong? You can't say it's a wrong model. All you can say is probably those are poorer models than 2 times the quantity. Okay, and again, I'm just saying probably for a good reason. We will see that shortly, right? So it's likely that those are not good models, but they're still models. So when you talk about the term model, we don't really say the model is right or wrong. All we are interested in is the model useful or not? That is something important to understand. Okay, now, till now, we've been looking at a very rosy picture of reality. Okay, in reality, things are not going to be just like that. Okay, straightforward, 2 times this, 4 times that, exact thing, and then every single row matches that. Okay, there would be some variability. So, for example, here, the total cost is kind of 2 times the quantity, but there is some variability, right? So for example, you've got 1.2, it just happens to be 2.5, not 2.4, but 0.3, it just so happens it's exactly double. 1.2 again double. 3, oh well, it's a little more than double. And sometimes it's a little less than double. Here 2.3 is 4.5, etc. Okay, this is how the real world will behave. In fact, real world will not even be as regular as this. The point is, in the real world, you're not going to get exact models. Okay, you'll get some approximate models. It is possible that your best model might still be total cost is 2 times the quantity, right? Because sometimes it's 2 times the quantity, sometimes it's a little more, sometimes it's a little less. So you cannot find an equation or a model that will make exact predictions. Okay, so it's only got to be approximate, and so this may still be the best model. Okay, so truth is the real world is complex, and we just have to hope for doing as well as we can. We can't expect models to find the underlying reality exactly. Why is that the case? Well, in reality, things are affected by so many different factors, and we are considering only a few factors. So in this particular case, we are predicting the total cost based only on quantity. Okay, maybe there are some other factors which play a role in determining the total cost, but unfortunately, we don't have access to data about those other factors. So therefore, we are restricted to working only with this limited data set, and from this is all we can do. Okay, so real world is complex. We should not think that our model will be able to capture all the essence of the real world. Okay, so don't expect to build exact models. In fact, don't expect to even build models that are even remotely close to exact. We'll come to that shortly. Okay, now another interesting example is that patterns can be of many types. So for example, one pattern we saw was try to find an algebraic equation like we did in the last case. We just found an equation. We said total cost is 2 times the weight. Boom, we got an equation. That's one kind of pattern. Okay, there might be other kinds of patterns. So for example, suppose you're given this data. Okay, you're given this data here, income and the status. Okay, status being, well, the income was 15,287, the person did not buy our product. Okay, the income was 86,693. That person bought the product, etc., etc. Okay, so once again, like before, take a look at this data, take a little bit of time, and try to see if you can spot any way by which you can predict based on the income whether a person will buy the product or not. Again, I would strongly advise you to put in the effort, take a look at the data, and write down how you will determine the status based on the income. Okay, and then continue the video. And then, of course, your job would be to use whatever model you found as a to predict values for these. Again, in this example, clearly your model cannot be an algebraic equation which says if which says the result is something times something or something plus something, right? Clearly, because here the result is not a number. Okay, so it cannot be computed numerically. Okay, so I assume you have now figured this out. Let's continue. Okay, if you take a look at this data closely, you will find that for all the people whose income is, let's say, greater than 65,000, they were all buyers, right? So 86,000 is a buyer, 74,200 is a buyer, 67,187 is a buyer. Everybody else has income less than 65,000 and they're all not buyers. Okay, so you may say if income is greater than 65,000, then the person is going to be a buyer. Otherwise, the person is not going to be a buyer. Okay, so now you come along here and you can make predictions. You can say 45,000. Oh, it's going to be not buyer. 75,000 buyer, 64,000 not buyer, 58,000 not buyer, non-buyer. Okay, so this was another kind. This is the model. Earlier, our algebraic equation was the model. This time, the model is this particular statement. If income greater than 65,000, then buyer, otherwise non-buyer. That's the model. Okay, that's the pattern that we observed in looking at the data. Okay, so again, this is a predictive model. It is capable of predicting the status. Okay, now the predictions may be good or bad, right or wrong, but it's capable of making predictions, and therefore it's a model. Of course, the things that we have looked at so far to motivate our concept of model, these were very simple scenarios. All we had to do was look at a small set of data, like 10 rows, and make a prediction based simply on the values in one attribute or one column. Real life is not so easy. In the real world, you've got data sets that look more like this. Many columns. Okay, and many rows, right? So you're going to have data sets which will have tens of thousands or hundreds of thousands or even millions of rows. Okay, and therefore it's not going to be possible for you to say, let me eyeball it and try to find the patterns. No way, right? Because there are so many different columns and you've got hundreds of thousands of rows. How are you going to look at the whole thing and try to figure out any kind of pattern? That's ruled out. Okay, so it's only a computer that can do all of that. Okay, so there are many predictors and there are many kinds of patterns. So for example, one kind of pattern we saw was an algebraic equation. Another kind of pattern we saw was that if this, then this, otherwise that kind of pattern. And there can be many other kinds of patterns as well. Okay, so there could be many complex patterns as well in the real world. So just relying on saying I'll always try to find an algebraic equation cannot work, or I'll always try to find a simple rule. No, that may not work. It may be much more complicated than that. And of course, another important point is you can only build approximate models. Your models are never going to be exact, meaning they're going to make mistakes. A lot of times the models will be wrong, but as we will see shortly, the models can still be useful. Wrong models can still be useful. Okay, so in this course, all we are going to do is to study many types of models for both classification and regression. So let's take a stab at a definition of what is a predictive model. So a predictive model is a procedure arrived at by using historical data, right? So we looked at some data and from the data we inferred a procedure. And it's a procedure to do what? It's a procedure to compute the value of an unknown attribute based on known attributes. In other words, we figured out a model to calculate the cost based on the weight, or to calculate whether a person is going to be a buyer or non-buyer based on income, right? So based on a known attribute value, in this case there was only one attribute value, but in reality it could be many attribute values. So based on known attribute values, we want to build a model to find an attribute value whose value we do not know, right? We do not know in the sense in future we don't know it, but historical data has that. So we are learning the pattern from the historical data and then applying it to new data for which we don't know the value. That's what we are trying to do here. Okay, and we'll refine this definition as we go forward. Okay, so we've been using the term predictive model quite a lot till now, and we also have the term called machine learning. And I said earlier, right in the beginning of the course, that I'm going to use those two terms pretty much synonymously. Okay, so you've got a data set, and up to now, all we were doing is this process, right? We are saying human examines the data and identifies the pattern. So for example, you examined the data for the previous two examples, you identified a pattern, you created a model. In one case, you said the cost is 2 times the weight. In the other case, you said if the income is greater than 65,000, then the person is a buyer, right? Those were your models. So you created the model. In other words, the model was created by a human. Ultimately, what we will actually be doing in reality, as I said earlier, because you're going to have many columns, you're going to have hundreds of thousands of rows. So there's no way a human being can actually examine that and try to do anything with it. It has to be done by a computer. So you give a data set to a computer. The computer examines the data and identifies the pattern and creates a model. So this is a model that is created by the computer. Okay, and this is what is of interest to us in this course. Okay, and this is what we call as machine learning, right? Because computer is a machine. The machine looked at the data and learned an underlying pattern. We didn't learn the pattern. We didn't look at the data, right? The machine looks at the data and learns the pattern. So that is why the term machine learning is used for this. And this brings us to the end of lesson 1.2.